Volume of a solid, cylindrical shell method. Consider a representative rectangle as shown in your figure, where W is the width of the rectangle, H is the height of the rectangle, and P is the distance between the axis of revolution and the center of the rectangle. When this rectangle is revolved about its axis of revolution, it forms a cylindrical shell or tube of thickness W. To find the volume of this shell, consider two cylinders. The radius of the larger and the radius of the smaller cylinder corresponds to the inner radius of the shell. Because P is the average radius of the shell, you know the outer radius is P plus W over 2, and the inner radius is P minus W over 2. Let me scroll. So the volume of the shell is the volume of the cylinder minus the volume of the hole. This part of the equation is the one we'll focus on when we get ready to set up our integrals later. Let me scroll a little bit farther. There we go. All right. So once this plane region starts revolving, notice in here it kind of looks like a cylindrical air filter. So we've got our axis of revolution, the solid of revolution, and we're going to integrate from left end to right end if this is our axis of revolution. Now, if the axis of revolution is on the y-axis, then we'll switch over, and that's going to be on your next slide, and we'll integrate bottom to top. Let me go ahead and go to the next slide. All right, to find the volume of a solid of revolution with the shell method, use one of the formulas below. I'm sorry, my highlighter kind of overshadowed in there quite a bit. It overshadowed the formulas in here. I hope they're still legible once this hits YouTube. If not, the Google Drive documents, you'll be able to find them in there. And you can look these up in Google Drive and you can print these documents as needed. All right, so if we have a horizontal axis of revolution, we'll use the formula at the top left of your screen. Will be 2 pi integrating from C to D. This P of Y, that's the average thickness. H of Y, that's the height. That'll be the function out of our problem. Then we'll integrate with respect to Y. So this is if the axis of revolution is horizontal. All right. So we have dy, h of y, p of y. If our problem involves a vertical axis of revolution, then we'll calculate volume as 2 pi integrating from A to B. The other one we integrate C to D. You always integrate opposite of your rectangle. So if your rectangle is going left to right, you'll integrate up and down, vice versa. If your representative rectangle is vertical, then you'll integrate left to right. P of x will be x, that's the, excuse me, the distance from the axis of revolution to the middle of your rectangle. And then h of x is your function that'll be given in the problem. That'll be the height of the rectangle. All right, so let's move down, actually do some examples. Find the volume of the solid formed by revolving the region bounded by y equals x minus x cubed and the x-axis between 0 and 1. So this upper arc, that's the function x minus x cubed between 0 and 1. P of x is equal to x. That's along the axis. That's the average radius. Once this thing starts revolving, that beige rectangle will form that shell. The height of the rectangle is our function x minus x cubed. So let's put all this together. Back to the left of your screen, 2 pi integrating from 0 to 1, p of x times h of x dx. P of x is x. H of x is your function x minus x cubed. Distribute, that's x squared minus x to the fourth. Antiderivative, or integrate, however you want to look at it, we have x cubed over 3 minus x to the fifth over 5, evaluated at 1, minus, evaluated at 0. That gives us 2 pi times 1/3 minus 1/5. When we sub in 0, that goes to 0 for a grand total of 4/15 pi. Yeah, I was looking at the wrong number. Let's look at another example. Find the volume of the solid formed by revolving the region by x equals e to the negative y squared, and the y-axis where y is between 0 and 1. So this is the other axis of revolution. This representative rectangle, once it's revolved, it'll form the cylindrical shell, and we're going to integrate from 0 to 1 this way. So let's set this up. Our volume will be calculated as 2 pi integrating from 0 to 1. P of y is y. Remember, that's the distance from the axis of revolution to the middle of your representative rectangle. That's just the distance of y. Our function in terms of y was e to the negative y squared. Multiplying, we get y e to the negative y squared. Due to chain rule, that derivative of the power is negative 2y. Well, we've got our y, but we don't have the negative 2. So it's okay to multiply in a constant. You just have to rebalance with its reciprocal. The 2 and the half, that'll reduce to a negative pi. Integrating, we get e to the negative y squared, evaluated at 1 and 0. When we plug a 1 in, that's e to the negative 1 squared, which is 1 over e, minus e to the negative 0 squared, that's 1. Multiply both numbers by negative pi, and that gives us negative pi over e plus pi. And if you wanted to reverse your order, then you have pi minus pi over e. Either of these answers is totally fine. And if you approximate to 3 decimal places, your volume is approximately 1.985 cubic units. Okay, and then I'm just going to let you read over this. This is kind of a recap of our disk and shell methods. You can find this in your e-text, and it'll have a little bit better explanation